This video is going to go over how to take a transformed trig function equation and make a graph from it. So here we can see an example of a trig equation. I have at the top y equals 3 sine of 2x minus 1. And we're also given a place to graph it. Now the first thing you always want to do is identify the midline and put it in your graph. In this case, I can see that my midline is -1. A quick reminder, the midline is always the number that is added or subtracted to the term with the trig ratio in it. So now I'm going to find -1 on my graph, on my y-axis on my graph, and I'm going to draw a dashed horizontal line there at -1. And I'm going to label it as my midline. Now this line is not part of my graph. It's just going to help me draw it. Now that you have the midline identified and placed on your graph, the next step is to identify the amplitude of the graph. In this example, the amplitude is 3. Remember, the amplitude is the number that comes before the trig ratio. Now, starting at my midline, I'm going to count both up and down 3 units. So 1, 2, 3 up to +2, and then down 3 units, 1, 2, 3 to this would be -4 from the midline. Let me repeat that. Start at the midline, go up 3 units, 1, 2, 3, and then start at the midline, go down 3 units, 1, 2, 3. This gives you the minimum in the graph and the maximum in the graph. Again, these dashed lines are not part of our graphs. They are just going to help us draw the graph. The last guiding dashed line we need to put in is a vertical line that will help us with the period. As you guys remember, the period is a little more difficult to find. It's not just staring at us from the equation, but it's going to involve this b term, 2. You need to remember that you take 2 pi and divide it by b to get the period. So I'm going to do 2 pi and divide it by 2, which is my b, which is going to give me just pi. So I know my period is pi. So I'm going to now find pi on the x-axis and draw a vertical dashed line there at pi. What that gives me is that starting at the y-axis and going to that vertical line at pi, I know I need to have one complete cycle or one complete period of the sine curve. The last thing I need to do before I draw in my graph is decide what my graph's actually going to look like. And that's going to depend on whether we have a sine or a cosine. In this case, we have sine. So I know that sine crosses the y-axis, so it crosses this at the midline. So I'm going to place a big dot right there. That just indicates to me my graph must go through this point. And then since we're doing an entire cycle in pi, or by the time we get to pi, I know that I have to be right back where I started at pi. So on the midline there, I'm at pi. I also know I need to go to the max and then down to the min before I get back to the midline. In order to do that, I'm going to have to cross the midline again. There's no way to get from the max to the min without crossing. So I can put in those 3 guiding dots, and then I just start at the first, I go up to the max, I go back down, making sure I go back through the second, and I end at the last one. A good way to remember it is sine always looks kind of like this, You can put 3 dots just like that in a line. Whereas cosine, you start at a max and you're going to drop down to the min and end up at the max. So when I put guide points in for cosine, I usually put 2 at the max and 1 at the min. Our last step is actually not always necessary. We're done drawing one period of our graph. Sometimes your directions may say to draw 2 periods, in which case you'll just copy exactly what you already did and sketch in another period of the graph. We know that this graph will actually go on forever, both to the left and to the right. We just won't draw the entire thing. Let's look at one more example, this time when we have a cosine function. As I mentioned already, the first step is always to identify the midline. In this example, the midline is a positive 1. So I'm going to draw in my dashed midline at positive 1, and I'm going to label it as the midline. The next thing to do is to identify the amplitude. In this example, the amplitude is 2. So starting at my midline, I'm going to count up 1, 2, and draw in my maximum at 4 and label it as max. And then starting again at the midline, I'm going to count down 1, 2 to negative 1 and label my minimum at negative 1. From here, I know that my graph is going to be entirely contained between these 2 pink lines. All of the curve will go up and down from the max to the min. Now I'm going to draw in the period. Again, the period is definitely the hardest part. The first part of the period is always to figure out what your B is. And remember, of course, that B is not the period. In this case, my B is 1/2. In my equation, that comes out as x divided by 2. But we know that dividing by 2 is the same thing as multiplying by 1/2. So now I use my equation that period equals 2 pi divided by b. Well, in that case, that's 2 pi divided by 1/2. But you guys know that dividing by a fraction, such as 1/2, is the same thing as taking the numerator and multiplying by the reciprocal of that denominator. The reciprocal of 1 over 2 is just 2 over 1. And now I multiply straight across the top, and I'm going to have that my period is 4 pi. So going back to the graph, I now know that if I was going to start at the y-axis, I better do a whole period by 4 pi. So I know now that I'm going to have an entire period of cosine in between these 2 blue lines. We've basically boxed off a period here, or a cycle. All that's left now to do is decide if my graph is going to look like this, like the little picture I just drew at the bottom, or more like this. The first one being sine, the second one being cosine. Well, I can see from my equation that it's a cosine. So I know I'm going to cross the y-axis at the maximum. So I put a big dot up here at the maximum. I know my graph is going to go through there. And since we do a whole cycle within that blue box, I know over here at the other corner I'm going to be back up at the top. And I also know I need to hit my min. It just so happens that we hit the min directly in the middle. So half of 4 pi at 2 pi. And now all I have left to do is just draw a pretty curve connecting all 3 of those dots. If I want to get fancy, I could put another dot out here at negative 4 pi, down here at negative 2, and make a whole period on the left, which is much less pretty looking. To get even fancier, I could talk briefly, get rid of that, about the domain and the range. The domain here is all real numbers, otherwise known as negative infinity. Let's go back a second. Negative infinity to positive infinity. Because I know that this curve, I've only drawn a little bit, but I know it's going to keep going forever. My range, though, is going to be bounded. And the nice thing here is we've already sort of drawn it in. We have our minimum down here at -1, so I know we start at -1. And then we have our maximum up here at +3. So I know that 3 is the top. Now that you've seen the video, it's time for you to try to graph some equations on your own. Here are two. Just be warned, in number 2, there's no amplitude given. That means that this number here is a 1. It's an invisible 1. It is not an invisible 0. Good luck.